In this lecture, we shall be looking into the reduction of fractions to its lowest term. Now, fractions can be reduced to its lowest term by dividing both the numerator and the denominator of the fraction by a common factor. Of course, you know that a common factor is a factor that is common, that is similar to both the numerator and the denominator here. So, to reduce a fraction to its lowest term, we are going to simply divide the numerator and the denominator of the fraction by a number that is common to both of them. Take note, lowest term means a term that cannot be further simplified, a term that cannot be further reduced. Okay, now let's look at some classical examples. The question says, reduce the following fractions to their lowest term. Number 1, 20 over 25. 2, 13 over 39. 3, 4 over 12. 4, 70 over 40. 5, 1000 over 80. 6, 3 over 4. Okay, we are going to reduce the following fractions to their lowest term. Now let's look at the solution. Okay, let's consider the first one, 20 over 25. If you look at these two numbers, 20 over 25, you are going to discover that the common factor between them is 5. When we talk about common factor, we are referring to the number that can divide 20 and 5 and 25 rather without a remainder. The common factor is a number that can divide two numbers without a remainder. So the common factor of 20 and 25 here is 5. It means that 5 can divide 20 and 25 without a remainder. Okay, so therefore we can now say, since we've known the common factor to be 5, hence it means that 20 over 25 is equals to 20 divided by 5 all over 25 divided by 5. Remember, we said that to reduce a fraction to its lowest term, we are to divide the numerator and the denominator by the common factor. So we have discovered the common factor to be 5 rather. So we now say 20 divided by 5 all over 25 divided by 5. Of course, 20 divided by 5 gives us 4, and 25 divided by 5 gives us what? 5. So this is what we have. So it means that the lowest term of 20 over 25 is equal to what? 4 over 5. Alternatively, we can use another method. Let's show you another approach to reducing this fraction to its lowest term. Now, so this approach we are going to use is called the cancellation method. So in this cancellation method, what we are going to do is to cancel out the common factors. See what we mean. Now, 20 over 25. We know the common factor to be 5. So we now divide, we now say, okay, we divide this, we cancel out 20, cancel itself, is what? 4. That is, we use 5 to divide it, right? What we simply say is 20 divided by 5, and that gives us 4, right? We now also say 25 divided by 5, that gives us what? 5. This is called cancellation method. So this now equals to what? 4 over 5. So these are the two ways of reducing a fraction to its lowest term. So whichever method you are okay with, you can use it. You will still get the same common solution. So it means that 20 over 25 and 4 over 5 are equivalent fractions. Please, we are using this opportunity to introduce you to what we call equivalent fractions. Two fractions are said to be equivalent if they are the same, if they represent the same number. So we can now say that 20 over 25 and 4 over 5 are equivalent fractions because both represent the same number. Okay, I hope you understand what we just explained. Let's advance to example 2. Example 2 says, reduce this to the lowest term, 13 over 39. Of course, the common factor between 13 and 39 is 13. So we're now going to divide the numerator and the denominator by 13. So we have this, that 13 over 39 is equals to 13 divided by 13 all over 39 divided by 13. So 13 divided by 13 gives us 1, and 39 divided by 13 gives us what? 3. So it means that 13 over 39 in its lowest term is what? 1 over 3. I hope you understand this. Okay, let's look at the alternative method, another method of doing this. So by cancelling out the common factor, we have 13 over 39, right? So we can now use 13, right? Because that's the common factor. So we say 13 divided by 13, that gives us 1. We now say 39 divided by 13, that gives us what? 3. So this gives us 1 over 3 as the answer. So it therefore means that 13 over 39 and 1 over 3 are equivalent fractions. Why? Because both represent the same number. Okay. Example 3. 4 over 12. The common factor is 4. 4 is a number that can divide 12 and 4 itself without a remainder. So we can now say that it therefore means that 4 over 12 is equals to 4 divided by 4 all over 12 divided by 4. 4 divided by 4 is 1, then 12 divided by 4 is what? 3. It therefore means that 4 over 12 in its lowest form is what? 1 over 3. Alternatively, that's another method. By cancelling out the common factor, we have 4 over 12, right? So when we use 4, then 4 goes into 4, that's 1, right? Then 4 goes into 12, that's what? That's 3. So it therefore means that 4 over 12 is equals to 1 over 3. Hence, 4 over 12 and 1 over 3 are equivalent fractions because both represent the same number. Okay, let's advance to the next example. Why we are solving a lot of this example is to help you understand what we are explaining. Okay, 70 over 40. The common factor here is 10. 10 is the number that can divide 70 and 40 without a remainder. So now, according to our rule, we're going to divide the numerator and denominator by 10. So what we're going to have is 70 over 40 is equals to 70 divided by 10 all over 40 divided by 10. 70 divided by 10 gives us 7, and 40 divided by 10 gives us 4. It therefore means that 70 over 40 in its lowest term is what? 7 over 4. Alternatively, we can use the second method by cancelling out the common factor. We have 70 over 40. Now, the common factor is 10. So if we say 10 goes into 70, that is what? 7. And we also say 10 goes into 40, that is what? 4. Another way to do this, of course, you can see 70 and 40. 0 and 0 is common among both of them. So you can just simply say 0 cancels 0. So what is left is 7 over 4. So it therefore means that 70 over 40 is equals to what? 7 over 4 in its lowest term. Hence, 70 over 40 and 7 over 4 are equivalent fractions. Please take note of equivalent fractions because both represent the same number. Example 5. 1000 all over 80. Now, what is common? The number that can divide both of them without a remainder. Okay, let's start with 10. The common factor here is 10. Now, please take notes. Follow me keenly here because there are some things I want you to understand. 1000 over 80. The common factor is 10. Of course, so it means that 1000 over 80 is equals to 1000 divided by 10, right? All over 80 divided by 10. Now, 1000 divided by 10 gives us 100. Then 80 divided by 10 gives us what? 8. Now, if you look at it, you can see that 1000 now over 80 is equals to what? 100 over 8. But this is not the lowest term. Remember, we told you that the lowest term is the term that cannot be further reduced. So if you look at 100 over 8, it can still be further reduced. 2 can divide it, 4 can divide it, right? So what we are going to do is that we are going to reduce it again. So whenever you are reducing a fraction to its lowest term, and after the first reduction, you discover that the term you got is not the lowest term, what is expected of you is to further reduce it again. So in this case, we are going to further reduce 100 over 8. So to further reduce this, the common factor here is 4. So you can see that 100 over 8 is now equals to 100 divided by 4 all over 8 divided by 4. 100 divided by 4 gives us 25. Then 8 divided by 4 gives us what? 2. Now if you check it out, 25 over 2 is the lowest term. It cannot be further reduced again. Hence, we can say that 1000 all over 80 is equals to what? 25 over 2. That is the lowest term. That means they are equivalent. Okay, let's show you the alternative way to solve this. They're using the other method, by alternative method, cancelling out the common factor. So we're going to have 1000 over 80. Of course, if we cancel out the zeros, we're going to be left with 100. And here we're going to be left with what? 8. Or simply, you can just use the common factor, which is 10, by saying 10 goes into 1000, that gives us 100. Then 10 goes into 80, that gives us what? 8. So what we're going to have left is what? 100 over 8. But this can be further reduced. So if we use 4 to break it, 4 goes into 100, that gives us 25. And then 4 goes into 8, that gives us what? 2. So therefore, this is now equals to 25 over 2. This cannot be further reduced. So hence, we can say that 1000 over 80 and 25 over 2 are equivalent fractions because both represent the same number. Okay, let's look at the last example, 3 over 4. Now, if you look at this 3 over 4, it has no common factor. So what does this mean? It means that 3 over 4 is already in its lowest term. So anytime you encounter a fraction like this and you check for its common factor, you discover that it has no common factor. It therefore means that that fraction is already in its lowest term. Okay, let's give you something to play with. Reduce the following to their lowest term. That's the question. Number 1, 70 over 150. Number 2, 38 over 66. Number 3, 84 over 108. Number 4, 28 over 20. Number 5, 12 over 15. Number 6, minus 24 over 30. Okay, we've come to the end of this particular lecture. In our next lectures, we shall be looking at fractions, lecture 4. Here, we are going to introduce you to the basic operations involving fractions. See you in our next lecture. Thank you for your attention.